A warm welcome to everybody, both speakers and audience members. Gregor Mendel is a name that's familiar to all of us from our school days. I guess that's more distant for some of us than others. For those of us who are epidemiologists here in Bristol, it's a name that pervades our everyday existence, having spawned the term Mendelian randomization, a statistical tool that we and others use to understand causality in a vast range of contexts. But the programme over the next couple of days doesn't really focus on Mendelian randomization at all. It peels back the layers of history to revisit the invaluable contribution that Mendel has made to modern day genetics, a journey that began with insightful observations in a modest rural setting, but recognised by almost no one at the time, and a journey that's moved into a discipline in its own right and has comprehensively influenced how we view the world around us, including understanding the molecular processes of life. So the first talk is an introduction to the conference entitled A Multitude of Mendels by George Davey Smith, a Mendel enthusiast and organizer of the meeting. Thank you, George, for proposing that this meeting take place. So George, as most of you will know, is a scholar and possibly as much a historian as an epidemiologist, who takes great pleasure in seeking out academic minutiae that others often miss. So I'm sure he'll have unearthed some interesting facts about Mendel to share with us in the first talk. Over to you, George.
Thanks very much. I'm an epidemiologist, and so I can only talk if I have a PowerPoint up. And as there's no PowerPoint up, I can't say anything at all because I'm just absolutely unable to speak without reading things off a PowerPoint. But I will say that the hashtag for anyone who wants to tweet is at the bottom of the program, is the hashtag Mendel 200. Okay. So I can now speak because I've got a PowerPoint. Yeah, so this is by way of an introduction, just an extended introduction to the meeting. And as I said, we're here obviously because it's the 200th anniversary of Mendel's birth. And as I said, I'm an epidemiologist, so why should I be interested in Mendel? Well, in around 2000, it became sort of possible to start including genetic measures in epidemiological studies. So like a few of the other older epidemiologists here, like Dave and Deborah, we started reading books on genetics to desperately pretend we were not time expired. So I have a pretty good idea of what a sort of common sense view of the story of Mendel was in 2000, because I had that common sense view from having done school biology and from having what passed as genetics teaching in medical school at that time. And the story was that Mendel was a monk. I knew that he was investigating inheritance, that he used peas as his experimental plant, that he demonstrated dominance and the recessive nature of traits, that there were two laws that we'd learned. There was the first law of segregation and there was the second law of independent assortment, that he had the concept of the gene and that there were alleles, there'd be different alleles at the same locus. So that's what I knew the story was. I also knew that, remembered from school, this rather interesting fact that he had written the paper, he'd done all this work, written the paper, and no one had read it. But there was the strange rediscovery, simultaneous rediscovery by the Dutch botanist De Vries, German botanist Karl Currens, and Churchmack, who was Austrian. And they'd all at the same time discovered Mendel's paper and done experiments to show the same thing. that in Britain, genetics arrived with William Bateson, and that Bateson, who was going to give a talk at the Royal Horticultural Society in 1900, or 1901, I can't remember, he read Mendel's paper on the train, and he changed his talk to discuss Mendel, and that this was a sort of launch of the Mendel enthusiasm in the UK. And of course, Bateson then in 1905 created the term genetics, so we'd arrived at genetics. So Caroline mentioned we're in this lovely Bristol Zoo, and if we'd come to Bristol Zoo, if we're here in Bristol Zoo, say 35, 40 years ago, we could go and see white tigers. We can't see white tigers today, so I'm going to use the white tigers of Ruhr and Clifton as a demonstration of the view I had of what Mendel had shown. A white tiger was captured in Ruhr, which was a princely state, now part of Madhya Pradesh, in 1951. And what do you do if you're a Maharaja who's got a white tiger? What you do is you put an advert in the Times and you try to flog the white tiger to an American zoo. I mean, luckily in a way for the Maharaja, no one picked it up, because what he then did was he bred the white tiger and got vastly more white tigers to sell, which he no longer had to sell through small ads, because people came to him to buy the tigers. He did this by the Mohan, the tiger that he had first got, was mated with Begum, who was an orange tiger, a standard orange tiger, and had all orange offspring. Mohan was then mated with one of his daughters, and then the daughter, and then from that mating came a mixed set of white and orange tigers. And it was from these descendants that the tigers in Bristol Zoo came. So using today's terminology, we can go back and infer what was happening. So Mohan would be it was thought instantly that this was a recessive trait. That was the assumption. Mohan would be a homozygous, recessive homozygote, but then therefore would have the phenotype, the white coated phenotype that was so highly desired by zoos. And in the mating of Mohan and Begum, a standard orange tigress, all the tigers were orange, but all the tigers would be heterozygous. So we could have peas here if we wanted in a different shape, but I think tigers are nicer. Mohan was then mated with his daughter, and his daughter was obviously a heterozygote, and they would be expected to have 50% white tigers and 50% orange but heterozygous tigers. Some other descendants of Mohan, who were both heterozygotes, were mated, and then they had the ratio, the sort of famous ratio, phenotypically of 3:1 that of course Mendel demonstrated with the traits in which he was doing his crosses. So you would have to expect 3:1 orange to white tiger. And then if we come to the Bristol tigers, so Bristol Zoo in 1962 bought Champak and Chinelli from the Maharaja, and these tigers were put on display, and they were credited for massively increasing the footfall in Bristol Zoo, the number of visitors who came to Bristol Zoo. And of course, it was eagerly anticipated that they would have offspring, and of course, when they had offspring, all the offspring would be white. So there's our Mendelian tigers and the link between Mendel and Bristol Zoo. And here indeed are 4 jolly offspring of Champak and Chinelli put on display in 1970 and appear to be undergoing growth monitoring already, because of course every pound is worth many pounds when you're talking about white tigers. And the footfall carried on being enthusiastic for white tigers. Geneticists, of course, wanted to check that their inference was correct, that this was just a straightforward dominant trait, and they therefore looked at all the matings that had been carried out And they looked at the observed versus the expected on just straightforward Mendelian ratios, and what they showed was a not massive sample size, but a pretty good, but they showed no deviation from expectation, and this appeared to be a Mendelian trait. And indeed, in 2003, this was identified. The causative mutation is just a single SNP leading to an amino acid change in a transporter protein, which leads to this big phenotypic difference in terms of color. This variant, though, does not go with any other health consequences. For example, it just makes the tigers look nice to some people, but it isn't. The mutation itself doesn't appear to have other consequences except some sort of microphenotypic ones. But you will have got the impression that there's a large amount of feedback coming through the door, which is making me feel that I'm a split personality. But that might be being turned down if we're lucky. So you will have got the notion that there's a lot of inbreeding going on to produce these white tigers. And Mohan, of course, was mated with his daughter, and it was indeed from that mating that Champak and Chameli, who were brothers and sisters, that Champak and Chameli came. So this was a brother and sister mating. Now you can work out quite easily that this is a vast amount of inbreeding. And indeed, inbreeding had consequences. These 4 happy tigers here were the 3rd litter. All of the tigers of the 1st litter died very soon after birth. In the 3rd litter, there was 5 tigers, but one of them died inconveniently before they managed to get the publicity photo, and 3 of the others were dead before reaching anything like reproductive age. So, there's clear massive health consequences. There's congenital malformations in every system, including kidneys, heart, etc. The tigers didn't survive very long. There was also a suggestion of increased aggression. These guys with these nice haircuts here, Siegfried and Roy, were the biggest act in Las Vegas for a long time. They were a magic act. They made tigers disappear and appear until one day, one of the tigers, whose name apparently translated into man-eater, attacked and nearly killed Roy, and that was the end of the act. So this sort of Bristol Post photo of Akbar, the rare white tiger, it's a jolly picture of him playing with Bristol zookeeper, might have a slightly more sinister edge. But you can't believe anything, though, by the way, in the Siegfried and Roy story. Every single aspect of that story is contested, although the cat dancers, the famous cat dancer trio, where the same tiger killed 2 of them shortly in short order, that story is there's no mystery of what happened in that case. Okay, so let's go back to the Monk's Tale in 2000 to continue that. The other part of what I knew about Mendel was that it was great tragedy, sort of tragedy for science in a way, that Charles Darwin didn't know of Mendel's work, because Mendel's work would have rescued Darwin from a conundrum that he was in because of criticisms from people like Fleming Jenkin, that the sort of blending inheritance which Darwin thought underlay phenotypic transmission, which he called indefinite variation or indefinite variance, that if that when that would blend, it would very soon disappear. So it would just be averaged out. So without a particular model of inheritance, it was difficult to defend against some criticisms the basic Darwinian model, and this period became known as the period of the eclipse of Darwinism from Julian Huxley, but then it wasn't Julian Huxley. I've forgotten who it was, but anyway, used by Peter Bowler for the title of his book about this period. So science would have advanced much faster if Darwin had only read Mendel, that part of the reason for the great neglect, following the great neglect, the tragedy was that we had the battling biometricians and the Mendelians, and so people like Raphael Weldon, who was a follower of Karl Pearson, and whose approach to the world was thinking that everything could be dealt with statistically and with continuous statistical models, and William Bateson, who was a sort of champion of the Mendelians, who thought that large mutations indeed underlay evolution, but they've battled furiously, and this sort of slowed progress. But luckily, the golden age finally arrived with the mathematical population genetics of Fisher, Wright, and Haldane, which managed to combine the notion of Mendelian inheritance, of small effect size, sort of infinitesimal model in Fisher's view, that those would produce things which looked like blending inheritance, looked like continuous inheritance, and that evolution could work on that and on mutations occurring. And so we had this happy evolutionary synthesis, and we sort of slid down the slide to endless happiness, which included, of course, sequencing of the discovery of the invention of the double helix, and sequencing of the whole human genome, etc. And that was it. So that was the monk's tale. But then in 2000, I started writing a paper about Mendelian randomization, which Caroline mentioned, and this term had been introduced by Gray and Wheatley in 1991 in a rather obscure publication, where they had this utterly brilliant idea of mimicking what you could see in a trial by matching siblings, by looking at children who were going to go on to have bone marrow transplant. And of course, no parents would allow randomization into a trial, because the mortality rate was terrible for the conditions that this was being, the hematopoietic cancers that this was being used for. But they said, well, bone marrow transplants are overwhelmingly more successful if they're from first-degree relatives, and that siblings, and that to a child who has such a tumor, if his sibling was compatible, and that was just a Mendelian, that was just a sort of random process through how they got the genes from the parents, that they were then more likely to get such a successful transplant. So you could do a sort of intention to treat analysis. Anyway, but this was then being developed. I think you could maybe apply it in different ways, just with single genetic variants related to traits. And Eleanor Sanderson will talk about this in detail tomorrow. Anyway, I was writing this paper about this method, and I, as Caroline mentioned, I tend to like to check things. So I thought I better check that this citation to Mendel's paper does actually have these two laws in it, and has what I'm saying in it. So I thought this would be an afternoon's job. So I went and I sort of read Mendel's paper. Well, there's no fucking laws in it. Well, I mean, there are, but they weren't the ones that I'd learned, except independent assortment. There was sort of a version of that, but there weren't these sort of genes, and there weren't alleles really described in that way. So what was going to be an afternoon was a sort of crisis meltdown that lasted about 3 months, and I started searching and reading everything I could, and then what you found was papers like Bob Olby's Mendel, no Mendelian. I thought, and you can imagine what this says, but it says, you know, other people will be talking about these things, so I'm not going to go into details about this, but I'll just show the title, so I won't say any more about them. You know, the reification of Mendel, and this reification was not meant in a good way, it has to be said, by Augustine Brannigan. Mendel's opposition to evolution and to Darwin. Gregor Mendel, an opponent of descent with modification. And then, this is more recent, but I like this one, Gregor Mendel, creationist hero. So I was just sort of expecting that my next search, I would get, you know, Gregor Mendel, serial killer, would come up as the next paper. But this is, but all I'm doing, I'm not going to say much more about this because this is what this meeting is going to be about. But suffices to say that every single part of the tale that I gave, I believed in 2000, every single part of that is wrong. But at least we know that we're celebrating Mendel's birthday. Well, that's in dispute because some people, many people think Mendel's birthday was actually July the 22nd. So even that it doesn't hold up. But I thought just to finish, I thought it might be worth looking back to think of all the anniversaries there have been for Mendel. Now there's been less celebration definitely of Mendel than with Darwin's anniversaries, because every year seems to be an anniversary of something important with Darwin, and to give an excuse for meetings. I mean, Mendel and Darwin are really interesting in sort of history of biology, I guess, because they're probably two of the most, if not the two most, studied examples or topics that people do history of biology work on. There's masses on both of them, and they are two utter extremes. With Darwin, we have vast correspondence which has been scanned in, and you can read it and you can discover new things because his handwriting is pretty cramped, and it's difficult to read, and so if you can actually got the patience, people haven't read all of it. With Mendel, and Darwin wrote diaries and corresponded with people enormously, but Mendel, on the other hand, there's very little, partly because his papers were burned. Either he burnt them before his death, or the abbot burnt them after his death, or there's many theories, and that's uncertain what happened to his papers. But there are some letters. There's a few letters. Some letters. There's Hugo Iltis, who went round and interviewed people after 1900. Interviewed people who remembered Mendel, but there's so little. So you have these two stories where there's just a sort of you're actually awash with material, and Mendel's story, in Darwin's case, and Mendel's story, which is the reverse. So the anniversaries, obviously the birth of Mendel, we can have anniversary, and that's what we're having today and tomorrow. There was when he presented in 1865 and then published in 1866 experiments on plant hybridization. Although we'll hear tomorrow from Staffan Muller-Böhl and Kirsten Hall, who are talking about translating Mendel at that, which should really be experiments on plant hybrids, and that there's a distinction. And again, with Mendel, one issue is just the translation. If you're English speaking, is the issue of translating the terms, and that the translations of the terms, what's been decided to be how you read across from German to English, actually influences what you think he was saying. So we'll hear a lot about that. 1884 was Mendel's death, but then 1900 was the birth of genetics. And 10 years after the birth of genetics, the Mendel statue was put up in Brno, which I've seen, this was put up by subscription. People sent round, people were written to and asked to provide money, to put money towards it. Bates and put money towards it and turned up. There was a big meeting held around it. Hugo de Vries refused to send any money. And then in 1922 there was Mendel's centenary, and this was a big celebration. In some places, the celebration was combined with the centenary of Gregor Mendel and of Francis Galton, who was also born in 1822. You might have noticed the somewhat quiet bicentenary of Francis Galton following, for example, the UCL Galton inquiry. And in fact, the only thing I could find was the Reverend Richard Coles, or Saint Richard Coles, as some we should maybe think of him, who did tweet a picture of Galton and said it was his bicentenary. Tragically, well, tragically might be going too far, appallingly, we have nonsense like this written because people know about the inquiries into Galton and know his absolutely straightforward racist language that he used, etc. This is Scientific American, so inverted commas around scientific, which is now a complete comic.
published this piece, and it says his predecessors, this is to E.O. Wilson, mathematician Carl Pearson, anthropologist Francis Galton, Charles Darwin, Gregor Mendel and others also published works and spoke of theories fraught with racist ideas. So crossing P's is somehow, just writing about crossing P's is somehow racist. And we'll hear tomorrow from Paul Weindling on Hugo Altis, who's Mendel's biographer, who spoke to everyone that Mendel knew, who was a heroic anti-racist campaigner against the rise of Nazism. So Scientific American refused to correct this statement. Hugo de Vries lived up to form, and in 1922 he again refused to come to a meeting, saying that the honouring of Mendel is a matter of fashion, that it's anti-British, and that it, like all fashions, it's bound to disappear. So at least we're here, so it hasn't completely disappeared. And anyway, you know, Hugo de Vries was no Mendelian either, but a famous paper on de Vries states. Then one of the biggest celebrations was in 1950, the 50 years of genetics. That was celebrating the sort of rediscovery. Now, what was happening in the world in 1950 was that in the Soviet Union, the rise of Lysenkoism, so Lysenko, who claimed to improve the yields of crops, etc., through generating acquired characteristics that were transmitted. And Lysenko was backed ultimately by Stalin. This led to geneticists like Vavilov dying in camps, and Mendelism was not allowed to be discussed and was rejected. So of course this fitted brilliantly for the Cold War. So the US celebrations in 1950 were part of a sort of affirmation of this sort of sense about science, if you like, in the West versus what was happening in the Soviet Union. So that was the 1950 celebration, and here's the volume from that. But there was many other celebrations in 1950. So, and then the 1965 to 1996. That was the centenary of experiments on plant hybrids, as we should possibly call it. This was a massive period of publication of new translations of Mendel's source books, of material, many meetings, individual monographs about Mendel. So there was just explosion of activity around that time. And of course, this included celebrating the double helix and the beginnings of molecular genetics. 1984, the centenary of Mendel's death, the Vatican put out a stamp, so that's pretty good. Amongst and there's some articles, but it wasn't a huge occasion. But then, of course, 2000 was the centenary of genetics. Now, that, of course, was also the year in which the first draft of the human genome was sequenced. And here we have Tony Blair, the way I like him, which is on a screen where you can turn him off. Tony Blair and Clinton celebrating the sequencing of the first draft of the human genome. Those huge amounts at this time did come up about this being 100 years of genetics, and it's just in 100 years of genetics that this has arrived, and lots of stuff written about Mendel, a popular biography which repeats much of the 2000 story up to 2000 I knew. Popular biography of Mendel as well came out in 2000. And 2022 is Mendel's bicentenary. So what does this have in store for us? Well, what this has in store is the sequencing of Mendel's genome. Mendel has been exhumed, and his genome is being sequenced. Here's the happy scientists who are saying that they got DNA, Mendel's DNA from hair, teeth, and bone samples that they match. And then they've now sort of looked at his mitochondrial DNA and his Y chromosome, and found that he was of typical Central European haplotypes, that he also had genetic predispositions to the health problems that he might have died of, which was renal disease and to heart problems when he died at the age of 61. As he said that he said to himself he was blessed by being chubby. I don't know if he thought he was blessed. It'll be interesting to see what his polygenic score for BMI is. But the issue about him being Central European takes us back to one of the other issues being discussed in this conference of eugenics. At least three talks touching on that, was that in 1923, Paul Popenoe, an enthusiastic and important American eugenicist who believed in compulsory sterilization, amongst other things, he was happy to report that Mendel was, pure, nice European origin, and the Professor Fritz Lenz was an enthusiastic eugenicist under the Nazis, who was happily reporting this. So possibly when one looks back at the anniversaries, and it might relate to today, maybe all histories that are written are contemporary histories because they reflect the times of the people who are writing them and what they see in the reconstruction of something which ultimately will never be fully reconstructible. And this was first stated with respect to Mendel by Niesel, who knew him well, who knew Mendel very well from the Brno scientific societies. And he said that the work was underestimated due to the spirit of the age at the time of its publication. It's well known but ignored in the prejudice raised by the divergent and mutually exclusive views current at the time. So maybe today's and tomorrow's centenary and the whole centenary celebrations around Mendel, including his exhumation and sequencing, reflect today more than they talk directly to Mendel. Thanks very much.